So tonight I'm going to tell you my super secret crowdfunding formula. And so what we found actually is not all that complicated. It was a lot of work. Spoiler, we actually were able to raise $25,000 for a basic research project. And it really came down to two essential components. The first, as depicted here in this little network, are social networks. So Facebook, Twitter. You have to have those. You have to reach out to these individuals and you have to turn them out and they have to give you money. And I depict them this way because I'm going to be showing you some data. I've actually crunched the numbers on my own Facebook network to actually dig in deeper to understand, is there a rhyme or reason to why people gave, and is that instructive for people going forward in crowdfunding? So that's one part, social networks. The other part is external media. You need strangers. You can't just rely on your friends or your followers unless you are Justin Bieber or who has a lot of name recognition, or you're someone like Neil deGrasse Tyson, who is very accomplished in their field, and people will believe, strangers will believe what you say. If you don't have that kind of following or friends, you need to have other people come and give you money, and how are they going to hear about you? So there's that component, the buzz. But these two simple pieces, a lot of hard work, sweat, and tears, enabled us to raise $25,000, which is a world record for basic science funding. So I'll tell you a story about how that happened. But first I want to sort of frame this as, why am I talking about crowdfunding? I'm a scientist. Maybe most of you have thought about crowdfunding in the context of the arts and music and writing and techie stuff and products like that. Not necessarily basic scientific research where there is no product per se. So I'm going to tell you, I think, a couple of secrets, dirty little secrets about academia that were part of the motivation for why I actually resorted to crowdfunding. It wasn't actually my first idea in terms of ways to get money, because there's actually traditional ways to get money if you're a scientist. And that touches on this whole budget issue. So most of the time, scientists in academia, and I should clarify this is all in academia, I'm speaking about my experiences in major research universities over the last 10 years. Most of the time, we are sort of squirreled away in a little bubble. And that bubble is either the bubble of our research, the bubble of our conferences where we go and chat with our peers about some esoteric topic, the bubble of our publications where we write up our results in jargon that really no one else understands except for like 3 other people in the world. And so we're sort of content living in this bubble. Oh, and then the rest of the time when we're not at these conferences or writing papers that no one understands, we're busy raising money. So I think scientists probably spend as much time raising money as politicians per capita, which is sort of shameful, but that's sort of the reality. So one dirty secret is that we're actually very tight for money, and it's gotten worse recently, as everyone knows about the fiscal cliff. One of the things on the chopping block is the budget of the National Institutes of Health, which supplies $30 billion of basic funding in America, which is the engine of basic biomedical research. This is the basic biomedical research that ultimately gets parlayed into new drugs, therapies that everyone really wants. So the dirty little secret is that we're really short on money right now in basic science, and we're also not really using our human capital very efficiently. So what do I mean by that? So I'm 33 years old. I just finished over a decade of training, first 5 years of graduate school, 5 years of postdoc fellowship, running my own small group at Princeton, and I was lucky enough to have my own budget to do that. But it turns out that in order to really do research in this country as an academic, you need to have a lot of money, hundreds of thousands of dollars a year. And this money is provided, like I said, by the government through grants. Now, it turns out that the big grant that one really wants to get is something called the R01. It supplies hundreds of thousands of dollars a year. It really is what enables an academic researcher to be truly independent and work on research over many years, right? Because the whole point of basic research is that you have to give space to let the creative process flow, and it's not like you can't have a deliverable on a certain date. That's just the nature of curiosity-driven research. Well, it turns out that the age at which scientists get their first big grant, this R01, has been getting progressively older and older as the years go by. So I want to play a little animation here. And what you'll see plotted is age and the fraction which people at a given age have this major grant. So the animation starts in 1980, and what you'll see is that all these bars are moving older and older and older. In other words, right now, you're 42 years old when you get your first big major grant from the government. So that's after spending 10 plus years training. You're basically supposed to spend your 30s, I'm not sure what exactly, but not deploying your great skills that you've honed as a basic researcher for all those years, right? You're basically in a holding pattern professionally. And so I'm 33. I don't really look forward to another 10 years of simply waiting around for me to get money to do the basic research that you all paid for me to do, because you pay for it because you're a taxpayer. I hope everyone here is a taxpayer. You pay for not only my graduate school, but you pay for the actual research. So you've invested in me as sort of an asset, but I'm not doing anything because right now I'm actually unemployed because my internship at Princeton was a non-tenure track position and ended after 5 years, and that's a very common situation in academia. So that's a lot of things that most people don't know, again, because academics live in a bubble and non-academics really don't have any idea what's really going on. They should, because you guys are actually paying for what we're doing. So that's one problem, is that you've got this misallocation of human capital. We're just, people my age are really hungry to do innovative, interesting basic research that will eventually hopefully lead to new drugs, in my case, because I'm interested in pharmacology, but we're sort of stuck because we don't have any money. The other problem is that it turns out that since about 1950, we've been spending more and more money to get fewer and fewer drugs. And so many people in this room might be familiar with this phenomenon called Moore's Law, to the idea from computers, right, that the number of transistors in a chip is going to double every 2 years. And so that's why, when I was a kid, I had a Commodore 64. Anyone remember what that is now? I, have that same computing power, if not much more, in this little device. So the exact opposite is happening in drug discovery, in the pharmaceutical industry, in other words. This pharmaceutical industry is spending more and more money to make fewer and fewer drugs. Now, people have coined that Aram's Law as sort of Moore's Law backwards. And that's a frightening secret. And again, this is something that we wanted to address because my research involves the way drugs work. So keeping in mind that there is this funding crunch, there is this, a lot of people, a lot of talented scientists are sort of waiting around to actually be able to do their science. I thought crowdfunding might actually be a way where something different can happen. It's not going to solve all of our ills, just like it's not going to solve all of society's ills, but it's going to be an interesting, I think, experiment, at least for scientists, because scientists really haven't been doing this much. So I want to show you a little video that we made, a 3-minute video that was part of our campaign pitch that was on the website. So we were on a website called Rocket Hub. So there's 3 big crowdfunding sites. Kickstarter, everybody's familiar with. Indiegogo is sort of the next one, and then Rocket Hub is number 3.
It is time to experiment with the way we experiment. We will use the internet to allow the public to fund and participate in a fully crowdsourced basic research project. The internet, itself the fruit of curiosity-driven research, has transformed every creative endeavor it has touched, promoting collaboration, openness, and efficiency. But scientists are stuck in a closed, free internet mindset. We aim to change that. So who are we and what do we want to do? For 5 years, Ethan Perlstein's lab at Princeton has been developing a new evolutionary approach to studying how drugs work. For nearly 2 decades, David Sulzer's lab at Columbia Med School has been a leader in the study of how drugs affect the brain. Our labs will now join forces to tackle a long-standing puzzle in mental health research. How does a family of drugs called amphetamines, which includes methamphetamine, actually work? Millions of people take these drugs every day, yet we don't fully understand what they do at the cellular level. How can we hope for new treatments to brain diseases or addiction without basic understanding? Simple, we can't. We will use a proven technique called autoradiography to figure out where these drugs go in the brain. Decades ago, this approach famously demonstrated that the psychedelic drug LSD works by interacting with specific neurotransmitter receptors throughout the brain. Autoradiography is really just radioactive photography. We'll start by injecting into a sample a radioactive version of the drug, which acts like a tiny homing beacon. Then, we'll expose brain tissue to film. The radioactive emissions appear as dark spots, revealing the drug's precise locations. By combining autoradiography with a powerful microscope, we will peer deep inside brain cells to resolve once and for all where amphetamines accumulate. The best part is, we don't know where it will end up, so the public will experience the thrill of discovery as it occurs. But to change the culture of science, we need your support and your input. To bring you closer to the action, we will make all data we generate freely available on the web. We will provide weekly blog and video reports detailing how research is progressing on the project's website. We will also hold regular online meetings to discuss results as they trickle in. And for the most generous supporters, we will offer the opportunity to engage in brainstorming sessions to help us make any scholarly publications resulting from this project intelligible to non-scientists. The light bulb wasn't invented by someone improving the candle. Together, we can create an open model of scientific research and communication for the internet age and beyond.
So that was a video that we commissioned from an LA-based videography and composer team, actually. That music was also composed originally for this piece. And this is what happened. So this is what a crowdfunding campaigns look like. And so here's where I go all Nate Silver on you and show you some data. What you see here on the x-axis are days. So we had a 52-day campaign. And then on the y-axis is the amount of money we raised. And for calibration, that dotted line that runs along the diagonal represents a sort of ideal world where you would raise an equal amount of money constantly every day and then just reach your target of $25,000 in our case on the last day. So that means raising $481 every day for 52 days straight. So it turns out that's really hard to do. And in reality, what actually happens is that you get a burst of activity in the very beginning, a burst of donations. Right? So these include people who sort of heard about the project in the days and weeks before because I talked about it on Twitter and on Facebook. So we had a lot of early adopters jump in. We actually had a launch party where we had about 60 people show up, and we had laptops where people could give, like a political campaign. Then things started to taper off. For about 80% of the campaign, we had this slow march up Everest here. And then we would get little spurts along the way, and sometimes that would be we got written up in some, on some blog or got written up by some science writer, so we got a little bump, but still sort of slow and steady. And then at the very end, we had this hockey stick finish, where we raised $5,000 from 124 people in 24 hours, and it was pretty incredible to be a witness to that. So this, I think, is actually probably how most crowdfunding campaigns work. You get most of the action in the very beginning or at the very end, and in the middle you just have to sort of keep treading water so you just don't stop. And NPR got interested in this story, and so they're actually interviewing us for a piece, and they had me commission a survey that we sent out to our supporters. So we ended up having just shy of 400 supporters. You think to yourself, well, who are these people who would give money for a basic research project to study where meth goes, right? Maybe meth heads would give. Well, they probably don't have a lot of money to spend on science projects. You think, well, maybe scientists would be the ones who'd be really into it. And it probably is true. So this was only about a third of our 400 people actually responded to this email and filled out our survey. But it looks like the majority, this big solid block of people in blue here are scientists. Okay, and that's at all levels, professors, graduate students, postdocs. That makes sense, right? It's by scientists, for scientists. But it's not just scientists. We had a chunk of people who were in management. That included people, say, for example, from McKinsey, or people who have some kind of executive experience in the science world, or not in the science world. It actually varied. Some people in the tech world. And then we had a few sort of oddball things. We had a hypnotherapist give us some money. And then we had one full-time mama, part-time web geek, self-described. So it gives you a sense of what these people do. Now, who are these people? So here's where I start to, and I'll end here. This is where we started to do some sort of network analysis. So I'm not sure how many people here are used to looking at networks, but over here on the left is a depiction of my Facebook network. So I have about 700 odd friends, and each one of them is a circle. Okay, and the size of the circle, or node, we use the word node when we talk in this sort of parlance here. Each node here, its size, is a reflection of how connected it is. So the really big circles are friends of mine that are friends with a lot of other my friends, right? And so the small circles are the people that I'm friends with, but none of my other friends are. So like some random person I might have met at a Lucid one day, let's say many years ago, or a year ago, that might be a dot there. But some of the big circles are, say, my bestie from high school. Okay, and they're friends with a lot of my other friends. The different colors correspond to these different clusters because friends represent different periods of my life. So a middle school cluster might be one of those, like in cyan. The one in purple there was actually a Burning Man cluster. I was at Burning Man for 2 years. Met some people at Burning Man. We have some burners out here. And so on and so on. And so that's the plot on the left. And it turned out about 17% of my Facebook network turned out and supported me at all levels, right? $25 was usually the average donation. And then on the right, I show the same exact network, but now I use the colors to show who gave money. Yellow here indicates a donor, blue is a non-donor. And so what was interesting here was that it didn't seem to be that there was just one solid group of friends, like say all my science nerd friends. They just went to town and gave me all the money. That wasn't true. we actually got a pretty good spread. All of these little clusters, we had some people turning out for them. And one conclusion I sort of had from that is that the connection didn't necessarily matter as much as the content. So when you're thinking about using crowdfunding to finance your creative vision, don't necessarily assume that only people who are into that particular thing might be the only people funding it. It could actually turn out that you have a bunch of high school, middle school, whatever friends that will give you money just because you haven't talked to them in 10 years, but they think fondly of you and then they give you some money. So we've been doing more analysis like this, including analysis of my Twitter network to sort of make sense of this, to sort of build a template here that ultimately I want to put out in the public domain so that other scientists, but not just scientists, anyone interested in using crowdfunding to finance their creativity can maybe use all this data that we have, because there's a lot more that I didn't show you because I'm kind of into data. But if we can put out a template to show people, this is how you could expect to run a campaign, where $25,000 is nothing to sneeze at. And so if anyone's interested in learning more about this, I'd love to tell you more about the details, and of course I'd love to tell you about the science. And I'd be remiss if I didn't show you this object here, which is a 3D printed molecule of methamphetamine. So this is the only blue meth you're ever going to get legally in New York City. So if you want to see what meth really looks like, come see me after the show. Thanks. About academia that were part of the motivation for why I actually resorted to crowdfunding. It wasn't actually my first idea in terms of ways to get money, because there's actually traditional ways to get money if you're a scientist, and that touches on this whole budget issue. So most of the time, scientists in academia, and I should clarify this is all in academia, I'm speaking about my experiences in major research universities over the last 10 years. Most of the time, we are sort of squirreled away in a little bubble. And that bubble is either the bubble of our research, the bubble of our conferences where we go and chat with our peers. So there's that component, the buzz. But these two simple pieces, a lot of hard work, sweat, and tears, enabled us to raise $25,000, which is a world record for basic science funding. So I'll tell you a story about how that happened. But first I want to sort of frame this as, why am I talking about crowdfunding? I'm a scientist. Maybe most of you have thought about crowdfunding in the context of the arts and music and writing and techie stuff and products like that. Not necessarily basic scientific research where there is no product per se. So I'm going to tell you, I think, a couple of secrets, dirty little secrets. I actually crunched the numbers on my own Facebook network to actually dig in deeper to understand, is there a rhyme or reason to why people gave, and is that instructive for people going forward in crowdfunding? So that's one part, social networks. The other part is external media. You need strangers. You can't just rely on your friends or your followers unless you are Justin Bieber or who has a lot of name recognition, or you're someone like Neil deGrasse Tyson, who is very accomplished in their field, and people will believe, strangers will believe what you say. If you don't have that kind of following or friends, you need to have other people come and give you money. And how are they going to hear about you? About some esoteric topic, the bubble of our publications, where we write up our results in jargon that really no one else understands except for like 3 other people in the world. And so we're sort of content living in this bubble. Oh, and then the rest of the time when we're not at these conferences or writing papers that no one understands, we're busy raising money. So I think scientists probably spend as much time raising money as politicians per capita, which is sort of shameful, but that's sort of the reality. So one dirty secret is that we're actually very tight for money, and it's gotten worse recently, as everyone knows about the fiscal cliff. One of the things on the chopping block is the budget of the national. So tonight I'm going to tell you my super secret crowdfunding formula. And so what we found actually is not all that complicated. It was a lot of work. Spoiler, we actually were able to raise $25,000 for a basic research project, and it really came down to 2 essential components. The first, as depicted here in this little network, are social networks. So Facebook, Twitter, you have to have those. You have to reach out to these individuals and you have to turn them out, and they have to give you money. And I depict them this way because I'm going to be showing you some data. I've actually